It's predominantly neighborhood buildings, nothing there that would indicate to me as the environmental engineer that there are contaminants in the soil or groundwater. If you look in the photo at the top left, the 1979 photo, that was taken after the construction of I-90. So between those two photos, nothing was placed there other than residential homes. Between 1979 and 2022, the only thing that was situated on that property was the Michael J. Zone Recreation Center. Based off of the information, there aren't any gas stations, dry cleaners, anything that would contribute pollutants into the soil or groundwater. I would recommend that there wouldn't need to be any sort of phase 2 assessments on the site. Moving forward, I decided to implement a gray water recycling system on the property. So first I had to estimate how much water would actually need to be held within my gray water recycling system. In order to do this, I conducted a survey within the greater Cleveland area, calling YMCAs and other recreation centers to estimate how many visitors we could potentially have on a given day. Luckily, I found a YMCA in downtown that had the same square footage as our building, or I think maybe off by 50 square feet, so relatively the same. And they were able to give me an expected number of visitors on a high day around 250 and a low day of 120. With these numbers and the estimated number of fixtures that I was able to predict in the building with the help of Luke and his architectural plans, I was able to determine that the tank capacity on a high day would need to be able to hold around 3,000 gallons of water, and on a low day, 1,500 gallons of water. As you can see in the schematic that I've created, this is how my gray water recycling system will ultimately work. I'll go into more detail about how my gray water recycling system will actually filter out the water before it goes back into the system, but essentially water from sinks, showers, and laundry machines will all be collected into my system to then await further processing. After the further processing, it'll be put back into the facility to flush the toilets and sprinkle the soccer fields. As you can see, all of the black water that's produced by the toilets will just go straight to wastewater treatment and will not be recycled. So here is a simplified schematic of what the inside of my gray water recycling system will look like. This system will be composed of predominantly 2 different filtration devices. So in the first section with the filtration, after it goes, all of the gray water goes into the collection tank, it'll go through a granular activated carbon that will remove anything like odor, color, anything aesthetic that you wouldn't want to see in your toilet water. You wouldn't want to smell something weird. You wouldn't want to see something weird. You don't want yellow toilet water if it's clean. Next, the mesh activated carbon. That will be a secondary step in the filtration process. So this will do a lot of cleaning within chlorine gases, other source organic pollutants. The secondary step is sterilization. This will get rid of any sort of bacteria that might have been left over in the first step in the filtration process. So the water will go through a UV antibacterial device before it's in my gray water storage tank. There it'll wait for it to go back into the system for flushing or for the sprinkling. I also decided to implement a rainwater harvesting system. As you can see here, this is a simplified schematic of what my rainwater system will include. I estimated based off of the roof square footage and the rain event that I got from the Ohio Design Code that the storage tank will need to be able to hold about 4,700 gallons per month. My system, some notable aspects of my system will be a screen filter at the gutter inlet and a first flush diverter, as you can see in the pre-treatment. So water from rain will land onto the roof. It'll fall into a gutter in which it'll go straight into pre-treatment. The screen filter will make sure that all of the debris on the roof, like leaves, bugs, dust, will immediately be cleaned and won't sit in the storage tank. The first flush diverter will be a secondary step to also eliminate any sort of smaller debris before it enters the cistern. Some downfalls to the first flush diverter is that it will need to be maintained quite regularly. After every rain event, someone will need to go out there, open the first flush diverter, and get rid of all of that contaminated water, just to make sure that the first flush diverter is clean before the next rain event. So the soccer field sprinklers, it's recommended in Northeast Ohio that you water your lawns and your fields so that they have an even 1-inch distribution on the field or the grass in general. In order to do this, I found a company that specializes in irrigation systems, and they recommended for a sport field of this size a 5-row system, which will include 8 sprinklers. I have them here listed, and each of the sprinklers will vary in gallons per minute between 33 and 65 gallons per minute, depending on where they're placed on the field. So to estimate my water demand and usage, I essentially had to divide up how much water I had left over after flushing. Because my gray water recycling system was producing so much water and the flushing only used about 500 gallons of water per day, I have about 2,500 gallons of water left over that I can use for my sprinkler system. It was also recommended when I mentioned the 1 inch of water on the sports fields that in order to determine what this 1 inch will be, you have to water your field between 10, 20, and 30 minutes to really determine whether or not you're getting that 1 inch evenly distributed. This will depend on the time of year, what time it is during the day, other factors like that. So as you can see, I divided up this graph between 10 minutes, 20 minutes, and 30 minutes. With my sprinkler estimates, I was able to determine that in 10 minutes, the sprinklers would use almost 5,000 gallons of water, 20 minutes, almost 10,000, and 30 minutes, 15,000. If we were to take all of the water I have left over from my gray water recycling system and my rainwater harvesting system in a given week, we would still need a pretty big amount of water left over from the Cleveland Water Department to supplement the amount of water that we don't have from the systems that I was able to recycle. And now I'm going to be passing this over to Tristan to talk about transportation.
Thank you, Emily. Yes, so I am going to actually make a parking lot fun for once. So for the transportation design constraints, we have 3 big major constraints that we have to follow. The first being, because of the location of the recreation center and the fields, those unfortunately weren't able to be moved unless Luke needed